Hey everyone, this is Mr. Backstrom, and today we're going to take a look at using our calculator, our TI-83 or 84 calculator, to identify a graph based off of the information given here. And we're going to use the window function in order to set our X domain and our Y domain. So the first thing it says is use a graphing utility to approximate the local maximum value and local minimum value of the function, and they give us a function there, and they also give us the domain of our x's. All right, so pulling up the calculator here, I will go to y equals, clear out my old equations, and pull that down a little bit, and then we're going to put this function in here. So it's going to be negative 0.4 times x cubed, and then minus 0.6x minus 0.6x plus 4x, minus 0.6x squared, excuse me, plus 4x and minus 4. All right, so double checking it. Looks good. So the next thing I want to do is I want to change my window size. So I'm going to go window, and for the x values, I want a minimum of -6 and a maximum of 4. So I'm going to put a -6 here, and I'm going to put 4 right here. Enter. And then we don't need to mess with the scaling at all. And then for my y min and my y max, I'm going to use -25 and 10 because they give it to us here in the problem. So we're going to go -25 and a y max of 10. All right, so now we can go right to our graph, and it's going to show us what this looks like. And if we kind of compare these, we can see that it looks like it's definitely this first one here, A. So we'll go ahead and check that. And then it says find the local maximum. And y is approximately, and we're going to round it to the nearest 100th at the x value. So here we go. We want to find the maximum here. So local maximum, and we can see it's going to occur right about here. So what we want to do is do second trace, and we're going to go to maximum, hit enter, and then we're going to give it a left bound, so something on the left of that maximum, and then a right bound. We're going to hit enter again, and we want to make sure that the highest point between our two vertical lines happens where we're trying to find that maximum value. Hit enter again, and it looks like we get an x of 1.39 and a y of -0.67. So we're going to go the y value first, which is -0.67, so -0.67, and then that's at x value 1.39. 1.39. Check. Very good. And then we want to find the local minimum. So the local minimum would be this valley here, right in this area. So we're going to kind of do a very similar function here. Second trace. Go to minimum. Enter. And then we're going to go on the left side first because it asks for the left bound. So it's just anywhere right on the left of that minimum value. And then we're going to go to a right bound, and again we want to make sure that the lowest value we're trying to find is between the two vertical lines there. Hit enter again. So we will put the -11.53 here, 11.53, and the x value to the nearest hundredth is going to be -2.39. So -2.39, we will check that, and there it is. All right, if you have any questions, please let me know, and I hope you have a great rest of your day. Thanks.